Okay. Good afternoon. I am Prabhakar Alok Verma, and today's lecture topic is GIS-based spatial analysis and non-spatial queries. The learning objective of this lecture is to understand concepts of GIS analysis. Basically, in this lecture, we will see what kind of questions GIS can answer, which cannot be answered by uh, trivial techniques. Then next objective is concept of suitability analysis and spatial and non-spatial queries. Spatial queries means queries which are based on location. For example, find out all the distribution centers which are within 100 meter of the main road. So this kind of queries are spatial queries. They need location information. Non-spatial queries are tabular queries which are performed over simple tabular data and no location information is needed. At the end of the lecture, it is expected that you should be able to answer, you should be able to understand the steps to perform spatial analysis. At least you should understand the idea of the spatial analysis, in which cases we need spatial analysis, the scenarios where this spatial analysis can help, and how to perform spatial location based and uh, tabular queries. Tabular queries simple, the queries which we perform in Excel or SQL or any other platform. Then different kind of vector and raster operations will also be covered. Vector means point, line, and polygon. So different kind of vector and raster operations will also be covered. Vector operation means of the operations which are performed over point, line, and polygon kind of data, and raster operations means operations which are performed over raster data. Raster is the data which is in the form of pixels or photograph, you can say. This kind of question the GIS analysis can answer. For example, if you are looking for a new location to establish a warehouse, or you are looking for a new location to establish a distribution center, so the spatial analysis can help you to narrow down the locations or preferred locations where you should establish the distribution center or a warehouse. Obviously, to establish this, you need to think of some criterias, and those criteria will be inserted in the form of operations, special operations, queries, non-special queries, and you will get the suitable result. We will see one example after covering the concepts of spatial analysis, means how to uh, apply GIS in such scenarios. Now, what is spatial analysis? So, spatial analysis, if you look at the definition, it is the process of extracting meaningful information from spatial data based on certain requirements. So nowadays we are having a lot of spatial data. Some is in the form of satellite data. We are having data from ground observation, IoTs. We are having vector data created by different agencies, different individuals. Data is available on open platform also. Many kind of data is available. What to do with that data? Until what is the purpose of having the data until we extract some meaningful information, some actionable item. If we are able to extract from the available data, then only it is of some use. Otherwise there is no use to have such huge data. So but to extract actionable information, meaningful information from the data, we need to have basic understanding of the operations which can be performed, and we need to have basic understanding of the data also. Accordingly we can frame our requirements, because uh, this meaningful information or actionable information will be as per your requirement, but your job is to frame your requirement in such a way that GIS can take it as a question. GIS can take it as a operation. So for that you need to have basic understanding of the system. So can this analysis includes basically queries, spatial and spatial as well as non-spatial. Spatial means location-based queries. Then spatial operations are also part of this analysis. Spatial operations can be like uh, integrating vector data as well as raster data, adding or subtracting any operation over raster data, basically performing mathematical arithmetic operations over raster data, performing spatial operations over vector as well as raster, like clipping, finding out intersection. So these operations are part of spatial analysis. Then network analysis is also a form of spatial analysis. In network analysis, the simplest example form of network analysis which we use mostly, that is finding out the shortest route from our source to destination. That is network analysis, and this shortest route can be based on the distance. This shortest route can be based on the travel time. Basically route can be based on any impedance factor, either time or travel time or distance, or any integrated impedance factor can also be used. Uh, Service area analysis, that is also network analysis. Service area analysis means finding out the effective region which can be serviced by any distribution center. So in a city you can have many distribution centers. So what is the effective region a distribution center can cover? So that is service area analysis, also part of network analysis or sub part of network analysis. So but in this lecture we will focus on this spatial operations, spatial queries, network analysis. There is separate lecture. Our objective is to focus on this. Role of What is the role of GIS in spatial analysis? So GIS is a tool with unique capabilities. What are its unique capabilities? It can handle geographically referenced data. It can create manipulate, update existing spatial data, basically shapes. It can uh, update, create, manipulate shapes. It can do the same for the attribute information also. Attribute information is the characteristic information about any shape. For example, when we uh, are making polygons for wards, basically suppose we want to represent ward boundary. So characteristic information of ward is the attribute of the ward. For example, area of the ward, that is one attribute information of the ward. Population of the ward, then working population of the ward, medical facilities of the ward, average temperature of that ward. So such kind of characteristic informations, uh, such kind of characteristic information are the attribute information of the spatial data. And GIS can also help with data conversion functions, converting one format of data to other format, vectorization and rasterization form. Suppose sometimes you may need raster data only for spatial operation, then you can use GIS to convert your vector data in the raster form. GIS also facilitates storage and organization of variety of spatial as well as attribute data. Manipulation obviously it does. Then display capabilities. GIS facilitates you to display the data, present the data in the form of map, where different color schemes can be given to the map based on the attribute values. A particular uh, shape can be highlighted based on the color scheme. GIS also facilitates you with the tools to perform spatial analysis. So basically these capabilities are related to handle the data, and apart from handling the data, you can perform spatial operation over the data. So all these capabilities makes GIS system unique. Now what do we need for the spatial data analysis? If we have to perform, if we are looking to perform spatial data analysis, so obviously we need a spatial data. So whatever analysis we are planning to perform, corresponding to that analysis, spatial data is needed. Spatial as well as non-spatial, basically data is needed to perform that analysis. Then once we have the data, we need a platform where we can uh, visualize the data, we can manipulate the data, we can perform operations over this data. That platform is our GIS platform, where we need basically a computing facility with GIS capabilities. So computer with GIS capabilities is needed, and the need of computing facility depends on the extent and scale of the problem. If you are looking to solve a problem for a very small region, for example, for a particular city or town, in that case, you need less computing facility. And if you are looking uh, to solve a problem for the whole country, in that case, you need more computing facility because data size will be very large. So basically, you need a computer with sufficient capabilities to handle the data on which you are planning to work. Then to perform the spatial analysis, we need to set the requirement, what kind of analysis need to be performed. That you will come to know after you set the requirement. What do you want? You want to select, you want to extract all the distribution centers which are within 100 meter of the road, or you want to select the distributions which are within 5 kilometers from the city center. And if this is the case, you may want to move your distribution center because of the traffic congestion around the city center. There can be n number of reasons to set any kind of requirement. Then according to the requirement, you need algorithm basically, and corresponding to algorithm, you need the tool to perform such uh, operation. So you need a algorithm or tool to perform a operation needed for your requirement. So once these operations are performed, at the end, visualization is needed. Basically, what is the output? What you were what is the output as per your requirement? That need the visualization is needed, because here data is spatial data which can be displayed in the form of map, and once you see any image, it gives you a better understanding and clear picture of the scenario of any area. These are some of the spatial operations where major operations are grouped under these group of functions. Measurement, retrieval, and classification, that is one group of function. Here we perform measurements and retrieve the data from our database or from the any format of the data. Then overlay functions. Overlay functions are basically functions where overlaying of two or more data set is needed. For example, if you are performing intersection operation means finding out the common between the two features, and if you have to do the intersection, so you will get something as written only if there is overlay. Then neighborhood functions, the functions which not only work based on the value at some given point, but they also need neighborhood information also. For example, if you are having some image, so if you are adding this image with some other image, you suppose you are having one more image. So in simple addition of two images, just assume this pixel information. So addition operation at this pixel will be will not need any other pixel information. Additional operation at this pixel will simply need pixel value at this point, at this pixel, and pixel value of this pixel, and simply it will add. So this is called local operation. But suppose you are finding out the moving average of the pixel. So to find out the moving average, you need neighboring pixel information also. So to find out moving average at this pixel, you need pixel information uh, of neighboring pixels. So that is one of the example of neighborhood functions. The measurement group of functions are used to perform geometric measurements before going to retrieval, let's see measurement group of functions. So measurement group of functions are used to find out the geometric measurements between features. So for example, you are having a road like this, and you are having a distribution center located here, and we want to find out the distance between road and the distribution center, then that will come under measurement group of function. And the distance which software will give you in return, that will be the minimum distance between road and the point. Suppose you are having distribution center A that may be marked by its boundary, and you are having a distribution center B marked by its boundary. So now if you have to find out distance between these distribution centers, then many distances are possible. In this case, this distance is possible, here to here, another distance. So to avoid this, distance between A and B is defined as the minimum distance between A and B. So whatever the minimum distance is there, that we will get in return by performing the corresponding operation. Then retrieval group of functions. These functions facilitate searching of the data. Searching means searching either based on location or searching based on attribute. For example, finding out all the cities which are having population less than 0.1 million. So this searching is based on attribute values. You are having a city information, and corresponding to each city, population information is added, and the query is performed over the population column of the table. So you will get the corresponding selection in return. Then query which is based on location, that can be of this kind. Find out the population living within 10 kilometers of distribution centers. So either total population living or target population, target user groups living within 10 kilometers, that way also this query can be performed. So this is based on location. So these selection queries can be based on three types: interactive, attribute conditions, and spatial relationship. We will see in detail one by one each of them. Interactive means you simply open the system, display the data, open the data, and interactively select the features from uh, using your mouse click. So for example, here is some data. Some data is here displayed, and in interactive queries, we can either go to attribute table and select the records attribute. This is the display of attribute table. This is how it looks like. So each record is corresponding to some uh, feature which you can see here. So each feature will have corresponding one record in the attribute table. So if you select any record from the table, corresponding feature will get selected. Or if you are selecting any feature here, the corresponding entry will get selected. For example, this was one of the queries: find all the cities having population more than 0.1 million. So you can look for the population field, and whichever uh, record is satisfying your criteria, you can keep on selecting. Correspondingly, this will be selected. And what is the use of selection? After doing the selection, you can extract the data from the whole database. That is one use. Other one is, if your requirement needs only some selected features, then you can select and perform the operations. Those operations will be performed only on the selected features. But here you can see, in interactive selection, it becomes difficult when there are a lot of records. For example, here only 40-45 records are there. So easily you can scroll down and choose the target record and select. But what if the case where you are having thousands of records? So in that case, looking for a particular record which satisfies your condition and manually doing this will become very difficult. Let's say you, from the cities list, you are having a city list of whole India, and you want to select Dehradun city out of that list. So if the cities of whole India are in the database, it will be a very large database, and selecting Dehradun, locating Dehradun manually will be a little time-taking task. So to avoid this, there are queries which are based on uh, conditions. So these conditions are based on relational operators. These are our standard relational operators: less than, equal to, less equal, greater, greater equal, and does not equal to. So this is the way of writing your query. So name of the field, followed by the relational operator, followed by the value. So this way you can write your condition, and you will get a result. So for example, this is your data, and you can just right click over the layers and find out attribute values. So here are the attribute values: some ID, then village code, name of the village, census code, and there is one more field total population. So I want to select all the villages or towns which are having population more than 10,000. So in interactive method, what we have to do, we have to scroll down and look for the entries in total population which are more than 10,000. It will become a very much time taking task, because here you can see total 700 features entries are there. So other option is using the query. So there is option select features using some expression. You can go there and type your query. What was the format, name of the field, followed by operator, followed by value. So field name either you can type or you can get from the list of fields. My field name is total population greater than 10,000, and simply click select features. So you can see here 9 features are selected, 9 features selected on the layer, and the selected features are highlighted here. So this way you can get some idea what are the regions which are having population or population density based search. You can also do population more than certain limit. So you can think of providing some facility here, uh, distribution center or some other business facility you can enable here, because a large user group can be found in this range. That can be one application of why we are performing these queries. So this query was just for one condition. There can be multiple conditions, and those multiple conditions can be combined using logical operators. So the combined condition is this. For example, now you want to select all the towns which are having population more than 10,000. Earlier it was just population more than 10,000. So if you see in this field, some were villages, some were towns. Now you are looking for town only or urban region only. So one more condition need to be applied here, and this is and is a logical operator. This will give true only if both the condition 1 and condition 2 both are true. If you use r in place of and, so in case of or you will get the true if any or both of the conditions are true. So here if you use that combined query, population more than 10,000 and level is town. So in that case, instead of 9, you will get 5 features only. Earlier 9 features were selected. Here 9 features were selected. Out of 9, 4 were villages. So after performing this query, those villages are removed and you will get only these selection. The same can be written here. So earlier we have written greater than 10,000. We can write and level equal to, we can get unique values of this and town. So this way 5 are selected now. And another use of logical operator is, suppose all the logical operators can be used and or not, and you can make the complex queries. Here suppose we are having a word information and we want to select all the words except some particular word. In that case, we can simply use the negate condition, not some word name equal to this. So wherever this condition is satisfied, that will not be selected, and wherever this condition is false, those will be selected. So this entry name is Rajput, so this is not selected and rest are selected. So this way we can make use of attribute condition based queries. And in this case, you can notice all these queries are performed on the information stored in attribute table. Till now, we have not used location based information. So that we will see from topological relationships. The topological relationships are also known as spatial relationships, and there are the 8 kind of relationships based on which the queries can be performed. These are disjoint, meet, equal, inside, covered by, contains, covers, overlap. So disjoint means where features are not overlapping, they are neither touching nor overlapping nor intersecting, nothing. They are separate features. Suppose you are having a feature A and feature B, they are not touching, not intersecting, no, touch is neither from inside or outside. They are separate features. So this is disjoint relationship. Overlap relationship. Overlap relationship. Overlap is nothing but the intersection relationship where there is overlap of some portion here. So feature A, feature B. So in case of overlap relationship, you will find the intersecting boundaries, in which case you need intersection. So for example, you are having a state boundary and each state is having its road network, and some are internal roads and some are national highways. So national highways generally cross the state boundaries, not always, sometimes. So, and suppose your warehouse is at some location X. This is your warehouse location, and from this warehouse you have to transport the goods to the state. So what are the possible ways which can be taken from here to here. So in that case, you can look for the highways which are crossing the boundary of state. So you find out the intersection of state with uh, road database, and you will find the highways which are crossing the boundary, and some highways will be going in different direction and some highway will be meeting your requirements. So you can do this kind of some preliminary analysis of the route. Later on you can use network analysis to find out the shortest route to reach from your warehouse to some distribution center in particular city. Then equal relationship is the relationship where two geometries are exactly of same shape, size and orientation. For example, you are having a shape A and shape B is also of exactly same size. So that is equal relationship. Then inside relationship. This relationship is sometimes is very useful. Anyway, all the relationships are very useful. So here, suppose you are having object B and outer polygon is object A, and your objective is to select the object which is inside. So query can be select all the distribution centers in Dehradun, select all the distribution centers in Uttarakhand. That kind of queries are answered by the inside relationship. So in this case, what will happen is when you are making the query, select all the distribution centers which are in Dehradun. So this way uh, you will get some result where the distribution centers which are inside Dehradun will be selected. So in case of inside relationship, whatever feature is inside that gets selected. So in case of covered by also, uh, inside and covered by they are same. Only difference is inside means completely inside, and here in case of there can be touching from the inside. Internal touching is possible. In case of covered by relationship also the inside feature gets selected, but there is touching. Where in case of inside the object was completely inside. Then uh, contains relationship. Contains relationship is just at looking that this example contains and inside looks similar, but they are not. In case of inside relationship, the feature which was inside that was getting selected, but in case of contains relationship, the feature which is outside that gets selected. So in case of inside, we took the example, select all the distribution centers which are in Dehradun city. So this way, all the distribution centers in Dehradun city were getting selected. In case of contains, select the district which contains warehouse of a company. So across the India, there will be many warehouse of some particular company, and they will be in some districts. So objective is to select the district which contains this warehouse A. Suppose this is warehouse A or this is warehouse X, and the district need to be selected. So in that case, contents relationship will be used and the district boundary will get selected here, not the inside. The feature which is outside that gets selected in contents. Covers and contents are similar, only difference is there is touching from inside. Now we will take a break of 15 minutes, then we will continue. Welcome back. Now we will continue our spatial relationships. Then after these spatial relationships, we will see one application of spatial operations. Meet relationship. In case of meet relationship, geometries touch at the boundaries, but this touching is from exterior, not from the interior. We have seen in covers there is touching, in covered by there is touching, but in covers and covered by, touching is from inside. Here, in covers, touching is from inside. But in case of meet, geometries touch at the boundary, but from the exterior, not from the interior. So this meet relationship helps you to find out neighbors of any polygon, neighbors of the country, neighbors of the state. Select all schools. So suppose you are having a ward map and this point data are showing the school locations, and if you have to select all the schools which are located in ward A. So for example, this is your ward A. So first step, this is multi-step query. First step is, since we are looking for schools in ward A, so first of all we have to select ward A. So ward A can be selected either using interactive selection method, or simply you can perform the query on attributes and select ward A. Then use inside relationship to select schools inside ward A. Apart from measurement and retrieval group of functions, there is another classification group of functions. In classification group of functions, basically we uh, either classify or reclassify the data. And why do we need classification or reclassification? Uh, this classification and reclassification. So reclassification is the process of classifying already classified data. Classified data does not mean secret data here. Classified data means the data where classes are made, categories are made, and simple classification works on the source data. So basically in classification or reclassification process, we assign a group of pixels, group of features to a particular class. So basically in classification process, we group the pixels or features. Why do we need to group? To reveal the patterns from the data. For example, suppose you are having this. So here population density is displayed. For example, this is ward map and population density is displayed here. So each ward will have different population density. So that's what is displayed here. Each ward is displayed in different colors. You are not able to understand that which ward is having more population density from this representation and which ward is having less population density. So what can be done to reveal this pattern pattern means which ward is having large population density, which ward is having minimum or medium population density. So you can think of identifying the wards where uh, more number of target groups, user group is available. So this way you can think of revealing the pattern. So here the population density or user group can be reclassified in the classes low, medium, and high. So where high class will contain a range of values. For example, population densities ranging between uh, 5,000 to 10,000. So that can be high. Low means less than population density is less than 100. Medium means 100 to 5,000. So any group can be made, logical group can be made for this low, medium, and high. And after this, you will see that most of the region is having low population density, and few regions are having high population density, rest are having medium population density. So, for example, if you have to focus on, yeah, for example, if you have to focus on Dehradun district, so you can see if suppose the all the villages, towns are displayed in single color, you will not be able to get any information just at looking at this figure. If you have to look, if you have to find out the towns which are having more population, you need to go in the attribute table and dig out that which of the towns or villages having large population. But if you classify it or apply color scheme accordingly, so easily you can find out that these are some of the regions having high population and rest they are not having high population. So basically all these are hilly regions in Dehradun. Only this is the city portion of this, the center portion, this one is Dehradun city, rest is hilly portions mostly. So Dehradun city is densely populated and rest a region is very much sparsely populated. So that you can reveal after applying the color scheme. So that is the use of classification. Now we will see one application of these spatial operations. So our objective is to identify suitable location for establishment of new distribution center in Dehradun district. Goods distribution center or any other distribution center you can think of. So if we have to establish a distribution center, few criteria we can think of. Uh, why do we need distribution center there, and what kind of, basically criteria means uh, what conditions the identified location should be satisfying for the new center. So first condition uh, can be the connectivity from major road. You are having warehouse somewhere, and from warehouse you have to transport the material to distribution center. So if this is the approach, then connectivity of the distribution center from the major roads should be very well, so that easily goods can be transported. So transport will be generally in bigger vehicle, heavy vehicles. So connectivity from the road is essential. Another one is number of users. So it should not be the location where you have established your distribution center, but number of users are very less. So you will not be able to make the profit or expected profit. So वहाँ पे you don't have to establish the center. Another criteria can be distance from the existing center. There should be some distance from the existing center. Suppose earlier there was already one center existed in the city in some particular district, but now because of increased demand of the products, increased demand of the service, you need to establish some more distribution center or sub distribution center. So there should be some the new center should be at least some distance away from the existing, then only it can cover the large target group uh, distributed in different extent. So if this information is available, that criteria can also be used. Then if you are establishing the center, there should be some criteria on land use types. There are different kind of land use present. One is like forest, water bodies. So obviously in forest and water body you cannot establish the distribution center. So there should be restriction on the land use types. So anyway, forest and water body, they are land covers. And uh, another criteria can be land use type should not be highly dense area. It should be away from highly dense area, residential. It should not be in residential area. That kind of restriction can also be put. Another restriction can be put here criteria that the it should be sufficiently away from the city center, because when you enter the city center it will be a heavy traffic zone. So to avoid entering of your good transportation vehicle in the heavy traffic zone, it's better to establish center outside. So that criteria can also be included. Then slope. In the district like Uttarakhand, where the topography is very undulating, slope is also a major criteria. You cannot establish a distribution center on uh, a region of having slope 45 degrees or 50 degrees. So you need a gentle slope to establish the center. So these are some of the criterias, and in detail for well connectivity from the major road, two conditions I have given. So if distance of the center is up to 100 meter from the road, it should be given a high preference. And if distance is between 100 meter to 200 meters from the road, it should be given second preference. And distance of more than 200 meters, should be restricted. So which means we do not want to establish our distribution center which is more than 200 meters away from the major roads, because if you go in that deep uh, if you go in that deep, you need to face the smaller roads, colony roads kind of thing. So that may be difficult for transportation of goods. So this is hypothetical example I have made. It is not necessarily 100 or 200 meters would be taken. Some other uh, condition can also be taken depending on the situation on ground. Then population. So population or target user group. So if uh, within 500-meter radius of any location, more than 4.5 lakhs people are living, then it should be given higher preference for establishment of the center. If within 5 meter radius around any point, 4 to 4.5 lakhs people are living, the second preference. If less than 4 lakhs people are living, then that point should be restricted from considering about establishment of the distribution center. And for land use type, we can in establish our distribution center in commercial land, but since data availability was the restriction, so for the demo purpose I have considered built up land as well as waste land as the criteria where distribution center can be established, and slope criteria. So whichever location is having slope less than 10 degrees, that should be considered suitable for establishment of a distribution center. So now how to do all these in QGIS. So let's first focus on this. Criteria is population within 5 kilometer radius. If it is more than 4.5 lakhs, first preference. Less than 4.5 and greater than 4, second preference. But how to identify such points? Now we will see in QGIS. So we are having this data, polygon data, and we want to find out the locations. We want to find out the each. We want to find out population around each location. How to do that? First of all, we need to mark such location. So for marking such location, you have to use the processing toolbox, search for fitness, create the grid. So grid will create the locations. So point type grid I want to create, extent where we want to create. We want to create grid for the whole region. Now it is asking for spacing. So I am giving 100-meter spacing vertical and 100-meter horizontal spacing. Then it is asking which coordinate reference system. So in GIS, since we are working on the latitude and longitude, and to display or to store these coordinates, we need a coordinate reference systems. There are two groups of coordinate reference system. One is geographic coordinate system and another one is projected coordinate system. So if we have to perform the linear measurement, we need to project the globe Earth, which is spherical in nature. We need to project it on a 2D plane. Then linear measurements can be performed. So for that, there are projected coordinate systems, and UTM is generally preferred as projected coordinate system. And since we are working on Dehradun, so UTM zone 44 north is the preferred projected coordinate system. In detail, you will see in next lecture what about the coordinate systems. So I want to save it somewhere. I will give name grid and run it. It is almost done. So here are the points separated by 100 meters. Now we will clip these points with the outer boundary of city. So for that we need to go for vector processing tool. Since this is vector data, point, line and polygon, we need to go for vector. We need to use vector tools which are present under a vector toolbox. And clipping means I just want to clip from the boundary. So input layer will be our grid, overlay layer is village boundary. So these are this is overlay operations which I am going to perform. Now clip grid. I will give name and run it. Again, it will take some time. It is done. So now you can see these points are clipped. I will remove the. So if you zoom in, you can see there are some points, and measure the distance. The distance between 2 points is 100 meters. 100 meters. 100 meters. Now, after having the points, our since our objective was to find out the population in 5 kilometer region. So first of all, next step is to mark the 5 kilometer region around these points. So to mark the region around these points, there is a tool named buffer, which is a area expansion feature. So you can mark the region around these points. So input is our clip these clipped points, distance of 5 kilometers, distance of 5 kilometers, and do not dissolve this 5 kilometer region. Now run. So this operation will basically make a 5 circle of radius 5 kilometer around each point. Later on, we will perform a overlay operation to add the population information present within that circle. So this way we will get the population around 5 kilometer region of the each point. So you can see the circles are made around each point. Since there are a lot of points, there are a lot of circles. It actually looks like this. There will be a lot of circles. So now we have to add the population information from Dehradun village image, Dehradun boundary here. This file is having population information. From this, we will add population information to our buffered region, 5 kilometer region. So for that, there is a tool named spatial join. Join attributes by location. So we will make use of this tool to add the population information. So where we have to join, so we have to join in our 5 kilometer buffer region. From where we have to join from this Dehradun village image. How wherever there is intersection, it will be joined, and what we have to join, that we can select from fields to summarize. So here 2_pop, that is the field which we want to join, and what we want to do with this field, whatever polygons are coming in that 5 kilometer range, I want sum sum of that population. So sum is selected. Now again save it. Now run it. It will join. Will take some time to join. This join process is taking too much time. So without waiting too much, we can see the expected result of join operation and move to the next. It will take a lot of time. We will see the result. So next step will be, after joining, we will transform the attribute information from the buffer layer to point layer, and we will rasterize it. After rasterization, next step is to select this as per the criteria. Now we have, uh, for each pixel, we know that what is the population in 5 kilometer region. So now we will do this. What is this? population within 5 kilometer range, that should be, if it is more than 4.5 lakhs, it should be given preference. If it is between 4 to 4.5 lakhs, second preference. So pixel values are reclassified. If population is more than 4.5 lakhs, that is uh, reclassified in green color. If population is between 4 to 4.5 lakhs, it is reclassified in blue color, which means this is the region where we can establish our distribution center. So in this region only we can establish the center. That is it, that this region we got by applying the population criteria only. So in this region, since population is very less, so it is not suggestible to establish the center. So this we got from one criteria. So pixel value of green color is 2, pixel value of this blue color is 1. Next criteria was uh, criteria of slope. So if slope is less than 10 degrees, which we have considered in our criteria here, we have considered if slope is less than 10 degrees, then only it is suggested to use that location for establishment of new distribution center, otherwise not. So how I have calculated, I am skipping this step from here. So we can get the elevation information from the satellite imagery. So from satellite image we get the elevation information, that is known as digital elevation model. And if we have elevation information, from elevation we can find out the slope. And since this is image, it is raster tool, we can simply use analysis slope and find out the slope value. So here this is the slope value. Each pixel is representing slope of the pixel. So for example, slope of any clicked pixel is this. So if I'm clicking here, these are the slope values. And now we have to select the pixels which are having slope less than 10 degrees. So for that, there is a tool named reclassify by table. So we can use this to select the pixels having value 0 and maximum value 10, we will reclassify it to new value 2. Okay, and you select check this use no data when no range value matches. So wherever it is uh, black in color, those are the regions having pixel value less than 10, and wherever it is white, those are the regions having pixel value more than 10, so they are non-suitable. So if we do the same for whole Dehradun district, we get this kind of reclassification. Here, uh, these green regions, they are having pixel slope value more than, sorry, less than 10 degrees. So this is the suitable location. Now, next criteria was land use type. So whole Dehradun city will have different kind of land use. So we can our criteria was that land use should be built up area or a wasteland. So out of the available land use types, the same reclassify method is used to select the land use which is either built up or wasteland. Then next criteria was distance from the major road should be uh, if it is within 100 meters, then more preference. If it is 100 to 200 meters, then lesser preference. So if you see road network of the Dehradun, so and open attribute table of this, you can find that there are different types of road: primary road, trunk road, tertiary road, and residential road. Many kind of road types are made, but our criteria was the distance from major road. So major road was considered we cannot establish a distribution center inside some colony where approach road is very narrow. So out of those roads, we will select the primary roads, and region of 100-meter and 100 to 200-meter around the primary road will be made as per our criteria. So here the center portion dotted line which you can see, so this center portion which you can see, that is road, and around road this is the green color, that is 0 to 100-meter range, 0 to 100-meter range from the road, and this blue color is 100 to 200-meter region range. So the pixel value for green is 2, pixel value for blue is 1. So now we are having these three: one map for the population criteria, another map for slope criteria, then another map for land use criteria, then another map for road criteria. Now if we combine all these criteria, we can simply add them. What we will get after adding? So right now what we are having one image which is having pixel values 1 and 2. For example, pixel value 2, another image having pixel value 2 here, another image having pixel value 2 here, and if we add them, what we will get? 2 plus 2 plus 2, 6. will be pixel value of this. So if 1 is here, 0 is here, 0 is here, pixel value of second pixel will become after addition 1. So suppose 0 is here, 0 is here, 0 is here. So we will get this as pixel value of third pixel. So this means wherever pixel value after adding all these criteria images, wherever pixel value is highest, that will be our most suitable region. So after adding all those criteria, we got this. These are some of the reasons where we can establish the distribution center. So you can just see out of the whole big extent, we could narrow down to this location. So we can even narrow down more. How we can narrow down more? One more criteria can be included. The criteria of distance from the city center. Here is the clock tower in Dehradun. So if we include the criteria that within 5 kilometer range from the city center, we cannot have the distribution center, then this region will also be nullified. We can't use this region because this is city center. So we will be left up with this region. So somewhere here or somewhere here. So 3-4 location we will get where a distribution center can be established. So this is it for today's class. You can ask some questions regarding this class if you have any.